Priya, kindly start.
Okay, sir. Good morning to all the respected present here. I, Engineer Priya Mittal, Assistant Professor, Department of Civil Engineering, BFCT, welcome you all on third day of our 1 week online faculty development program sponsored by AICT, IST on recent developments in AI and robotics. Now, I would like to welcome our today's second speaker, Dr. Kumar, founder, director, and first promoter of Magma Research and Consultancy Services India. His qualifications integrate MCA, MPhil in Computer Science, MTech in IT, PhD in Computer Science, LLB, and IBM Certified Associate Developer. He obtained the international certifications in data science, Python, blockchain programming, machine learning, software testing, and related technologies from corporate giants including IBM, Google, Accenture, and many others. He possesses more than 18 years of experience in teaching, industry, and research. He delivers the practical hands-on sessions on recent technologies in workshops, faculty development programs, short-term courses, and technical events as resource person in various states of India. On behalf of Baba Farid College of Engineering and Technology, we welcome you, sir, to speak over today's topic, machine learning algorithms and their use in robotics. Thank you so much, sir.
Good morning, ma'am. Is it good morning to all? Is it audible to all of you? Good morning.
Sir, your voice gets cracked.
Please confirm, sir. Is it audible to all of you?
Yes.
Yes, sir. Please confirm. Is it audible to all of you?
Yes, it's
Are you
audible.
getting audio?
It's
Okay,
audible.
fine. So should we start the session, sir?
Yes, sir. Kindly.
Okay. So, good morning to all the participants and organizing panel of this FDP. We are starting today's session and I'm sharing my screen just now so that we can start with the today's contents. Is it visible as well as audible to all participants? Please confirm once.
Yes, sir, it's visible.
Are you getting audio as well as video clearly?
Yes, sir.
Okay, so in today's session, we will discuss about machine learning and its implementation for robotic applications. How to integrate artificial intelligence, how to associate artificial intelligence and machine learning for real world scenarios. We will see in this session. And most of the implementation scenarios will be in practical hands-on. So we will see some real-time demonstrations using programming scripts. First of all, we will discuss about the base of artificial intelligence and machine learning. Which type of devices, which type of infrastructure we can use while working with robotic applications. And in minimum cost, whenever we discuss about the implementation part of robotic applications, it is generally thought, it is basically misconception that it will cost very huge amount. But in less than 1000 rupees, in very minimum cost, we can work with very effective robotic applications. And we will see which programming platforms are available, which programming scripts we can integrate for different applications of machine learning and artificial intelligence in robotics. Is it audible to all of you? Please confirm once. Once again, I want to confirm, is it audible as well as visible to all of you? Are you getting audio clearly?
Yes, yes, sir.
Okay. So as you can see in this slide, we have mentioned certain key points along with some devices. We'll see how to use open source hardware, how to integrate open source hardware. First of all, we will discuss about what is actually open source hardware. Whenever we go for robotic applications, or if we want to develop a particular robot along with machine learning, in that case, which type of devices we can use? Robotic means what is actually robotics, or what is actually robot at the base level? How, by which way we can integrate it? We are taking very simple example, very simple scenario we will take. Suppose I want to work on a research project, and in that particular research project, I want to implement real-time data capturing, real-time video capturing, and evaluation of social distancing. Suppose I want to develop a particular robot, I want to work on a particular machine, and that machine should be installed at a particular traffic light on a particular and it is automatically capturing the nearby images of different people.
Sir, your audio gets cracked.
It is capturing images, it is capturing video of nearby objects, and it is evaluating in dynamic mode whether two objects are having, whether two persons are having this much distance or not. So it is one scenario of real-time data extraction, prediction of followed or not in a crowd area. So it can be one of, for that what we can do, we can take a Is it audible now? Please confirm.
Yes, sir. Now it's audible.
Okay.
Your voice gets
So,
cracked
so,
sometimes.
earlier example is clear that suppose I want to make a particular device, I want to work on a particular robotic application that is capturing data from nearby objects, and it is evaluating the distance. It is evaluating whether two persons or multiple persons are maintaining social distance or not, whatever it is, whatever we have set in that particular machine. So that is one of the robotic application, real time data capturing by webcam, real time data capturing by a specific camera, and it is evaluating whether all of these people are human being or not. That is object detection. So first part is webcam integration. So in only 300 or 400 rupees we can get a hardware. You might have heard about of a hardware that is Arduino. Arduino is basically a motherboard, base motherboard. It is basically a computer. Okay, and this is the image. Is it visible to all of you? This image of Arduino, is this visible to all participants?
Yes, yes, sir.
Okay. I have opened my chat so that I can see your messages. So whenever I will ask you something, so I request to respond in this chat so that I come to know that you are getting all these things. Okay, so you can see what is this. This is Arduino board. Okay, this Arduino board is available in market in only 400 rupees. And this Arduino board is having equivalent powers that is available in a motherboard, in a computer motherboard. And you can see different slots are available. So in 400 rupees we can take Arduino board. In 2000 rupees, in 3000 rupees we can get Raspberry Pi. Raspberry Pi is another open source hardware. Open source hardware means which we can customize, which we can modify according to our requirements. Which requirements? Suppose I want to work on a research project for real-time criminal data. So whether a particular object is or not, because it at time things. There may be some techniques, there may be some outputs, there may be some statements. Okay, and classification and predictions.
Participants kindly wait. Sir will rejoin us very soon.
Uh, is it audible now? Please confirm.
Yes, it's audible.
So I apologize that because of some
What issue, sir?
network issues we are facing
What
such
issue?
problems. So we were discussing about. So now is it audible as well as visible to all of you?
No, sir, you have to share it again.
Just a minute. Yes, is it clear
Yes,
now?
yes, sir. Yes, sir.
So, so we were discussing about some research perspectives on machine learning using some open source hardware. So which open source hardware? Arduino. Arduino is available in only 400 rupees. In 2000, 3000 rupees, we can get access to Raspberry Pi. And beyond these open source hardware, there are so many hardware objects available which we can customize to create our own implementations, to work on our own implementations. Okay, so these open source hardware are available in very less cost, and it is having all the ports, it is having all connectivity ports for webcam, for speech recognition, for mic, for speaker. So suppose I want to work on a particular application for cyber forensics or for law enforcement agencies. So what we can do, we can take this particular board, Arduino board, it is open source, we can integrate webcam, we can integrate a specific platform of machine learning. Now we will see by which way this particular platform, this hardware will check whether all of these objects are human being or not. By which way it will analyze, by which way it will detect whether it is human being or some still object or some animal or any other flying object. For that, we are having a specialized platform of machine learning with name OpenCV. OpenCV that refers to open platform of computer vision. So OpenCV is one of the very powerful application, one of the very powerful platform that is programmable in C, C++, Java, Python. So in whatever programming language you are already comfortable, you can use that particular programming language with OpenCV. So what is OpenCV? OpenCV is a platform. OpenCV is a framework that is available in free and open source distribution. And it is having all machine learning algorithms which we need for object detection, for criminal forensics, for law enforcement agencies, for social distancing. So whatever you can think, each and everything is available. If you want to work on machine learning for identification, whether this particular object is under that class or not, that is available. And nowadays, more than 90% real-time robotic applications are getting developed using OpenCV. It is programmable with webcam, with mic, speakers, automatic speech recognition, automatic object detection, automatic face recognition. Automatically, we can work with OpenCV for biometric recognitions. Okay, and there is no foundation of programming language. There is no need to work on a specific programming platform. If you are comfortable in C, then its APIs are available for C language. APIs means its interface is available for C language also. If you are comfortable in C++, its interface is available for C++. Okay, if you want to work for Java, if you are already comfortable in Java language, then its interface is available in Java. So in multiple programming languages, it is providing interface. Okay, so what we can do, if I repeat this point, in very less amount we are having open source hardware. This open source hardware is a motherboard. Okay, inside this hardware we can install OpenCV, and it is having all machine learning algorithms, all knowledge discovery algorithms, and there is no need to do any type of programming. Simply we have to call the APIs, gesture recognition, facial recognition, 2D, 3D feature toolkits. Even if I want to create a drone, suppose I want to develop a drone for law enforcement agencies. Okay, at the time of curfew, suppose we want to present that particular drone to police agencies, to law enforcement agencies, that automatically it will identify from which longitude, latitude, from which particular location these persons are out of their home. These these are the suspects. So that drone can also be developed, that can also be integrated in less than 2000 rupees. So webcam will be there in Arduino, and inside that we can put some additional ports, and in dynamic mode it will capture data, it will capture the gesture, and it will analyze whether these gestures are associated with human being or not, whether these facial expressions are associated with some human being or not. Same type of implementation we can propose for some public places like railway stations, airports, so that if some particular criminal is moving out from a particular location, that can be identified dynamically. Okay, so what we can do using OpenCV platform, that is Open Computer Vision, it is having all machine learning algorithms. It can be integrated with open source hardware, and with API calling. I will show you its demonstration also, by which way it can be done. Okay, if we relate it for financial transactions, suppose for banks, in banking system nowadays the signature recognition is one of the very important tasks. In current scenario, signature matching is done manually. Whenever we deposit some checks in the bank, what they do, they scan those checks and they send it for clearing house. In clearing house, the people identify whether these signatures are matching with the database of signatures or not, and then they approve or disapprove it. But this thing can also be automated using OpenCV. We will see in 2 to 3 lines of code, in 5 to 6 lines of code, we will be able to work with real-time video extraction, real-time check matching, dynamic forgery detection, dynamic dynamic mode of human detection. In real time, we can see whether this person is human or not. In dynamic mode, we can work with biometric based recognition. So all of these features are available in OpenCV. Okay, up to this point, is it clear to all of you? Please confirm once. I have opened my chat. You can respond in chat only. Up to this point, is it clear? Whatever we have discussed, we have covered only 2 3 points. One is open source hardware, that is Arduino or Raspberry Pi, that we can take for some research projects, for some real-time robotic applications. That is open source hardware. It means that we can program it depending upon our application, depending upon our research statement. Okay, inside that open source hardware, we can install OpenCV. OpenCV can be downloaded from this opencv.org. So I'm opening the official library, official URL of OpenCV. Okay, is it visible to all of you? Is this screen visible to all participants? opencv.org, and it is providing the bundle of machine learning and artificial intelligence algorithms. Are you getting this screen? In chat, please confirm. We can download it. Is it audible, sir? Please confirm. Are you getting audio as well as
Yes, sir. Yes, sir.
screen?
It's completely audible and visible.
Okay, okay. So you can see it is freely available. So I request participants to respond so that I come to know that you are checking it. So you can see that different applications are mentioned here. Different case studies are mentioned here. So OpenCV is free and open source platform, free and open source distribution for artificial intelligence, for machine learning applications. We can install it in our laptop, we can install it in open source hardware, we can install it in a bare machine. Bare machine means open source hardware. So obviously we can't put our laptop on traffic light. Okay, I'm repeating this point very clearly, listen it. I can't put my complete laptop on a traffic light just for recognition of human, just for recognition of social distancing, just for recognition of whether some particular criminal is moving out. Okay, but if I get a miniature of laptop in 4 by 4 centimeter size, in 10 by 10 centimeter size, so that 10 by 10 centimeter size that is associated with open source hardware in 200 rupees, in 300 rupees, even in 100 rupees also it is available. So in 50 rupees or 60 rupees we can integrate webcam, and inside that open source hardware we can install OpenCV. So in maximum 400 or 500 or 1000 rupees we will be having a mini robot, mini robotic application that is dynamically capturing images using webcam. Inside that motherboard, inside that device, OpenCV is also available. And inside OpenCV, we have trained database of criminals. We have trained database of different objects. And using speaker, it is giving prediction. Or using display, using LED, or using LCD, it is giving us some knowledge. Okay, now we will see how to work with this. So as we have mentioned that it is compatible with multiple programming languages. Whether you are working on MATLAB, you can program with Octave or Scilab or Python or Java. There is no restriction, there is no foundation that we have to program in Java only, we have to program in Python only. We can program in any programming language. We can code in any programming language. Okay, so and these algorithms are already available on in OpenCV. So no need to work on hardcore coding, no need to write lengthy codes, and all statistical methods, all machine learning approaches available in this platform. Okay, as you can see here. So if I want to work on decision tree, if I want to work on gradient boosting trees or whatever it is, each and everything is available in OpenCV. So without any programming, without any, without writing any long lines of code, we can work with it. Okay, and supported for multiple platforms, even on Android also, even it is compatible for mobile applications. Okay, you can create your mobile, or you can transform your mobile as a robot also. So if I install OpenCV in Android phone, in that case it will work using those machine learning algorithms which we have integrated, which we have called. Okay. Is it clear up to now? And after this, I will start the implementation part. Up to this point, is it clear to all of you? What is OpenCV? So till now, we have not seen any demonstration. Till now, we have not seen any implementation part. We have only discussed about what we can do. Okay. Up to now, is it clear to all of you? In chat, please respond. What is OpenCV? And we can use it in open source hardware. Now we will see how to integrate OpenCV with Python. We will see its implementation part. And I'm starting it. So you can see that these are different chips available. Even for agriculture purpose also, we can create some robotic applications. You might have seen nowadays so many robotic applications are being developed for agriculture. For example, suppose I want to check for a particular crop, whether it is rice or grain or whatever it is, that this much chemical formation is required. So suppose this much mg of sulfur is required, this much mg of hydrogen is required, or this much chemical formation is required in a particular soil. So what we can do, we can integrate some sensors. In 50 rupees, 100 rupees or 200 rupees, we will get different sensors. Multiple types of sensors are available in market. So in open source hardware, we can integrate those sensors. These sensors will identify the soil quality. That particular value associated with each and every chemical will be evaluated using OpenCV. It will detect that how much sulfur, how much hydrogen, or how much this particular chemical factor is required for this soil. And using Wi-Fi slot inside that OpenCV, inside that open source hardware, it will transmit data to satellite, it will transmit data to mobile phone, and the farmer or agriculture scientist can check that, okay, this much percentage of this type of chemical is lacking, and we should put this type of medicine, or we should put this type of object. So whether you are working for criminal forensics or we are working for agriculture, we can use such platforms in minimum amount. Okay. Now we will see how to integrate it, how to use it. So is this code visible to all of you? How to work with webcam interfacing with OpenCV. Now I'm starting the demonstration part, how to work with OpenCV, and in minimum lines of code, we can create very effective applications. Is this visible to all participants? Please confirm in chat. Are you getting this screen? Whether this source code is visible to all of you? Okay. Now you can see that this is very simple source code for webcam interfacing using OpenCV. You can see that import CV2. So if I copy this source code in a particular machine that is having OpenCV, and that machine also do not require any specific infrastructure, it do not require any specific hardware, this particular code is compatible with OpenCV, and you can see that with single line of code, that CV2, what is CV2? CV2 is OpenCV. CV2 dot video capture. So with only this line of code, it will identify, it will capture images from webcam. So you can see that in video, CV2.video capture 0. It means it will capture data from first camera. You might have seen in a on every traffic light there are multiple cameras. Suppose in a traffic light we have integrated 5 cameras. I want to take image from third camera. In that case, we can put here 2. So 0 for 1, 1 for 2, and 2 for 3. So for third camera, we can put 2. Okay. And in real time, it will capture images. And whatever images are getting captured, we can match all those images from a set of images which are associated to criminals. And by which way that matching will be done? With minimum lines of code of OpenCV, we can do it. If we perform same thing without OpenCV, then you will be surprised to know that we will have to write at least 2000 lines of code. So with OpenCV, we are performing this thing in 5 or 6 lines or 10 lines, but without OpenCV, we have to perform in at least 2000 lines of code. If we are having a set of faces, set of images which are related to criminals, and we want to work on a particular research project for dynamic extraction of images from crowd, and from each and every person in crowd, we want to match the face with criminal's face. With OpenCV, it can be done in 5 to 6 lines of code. Without OpenCV, it may cross 10,000 lines of code. So that is the beauty of OpenCV platform. Inbuilt machine learning is available. Inbuilt biometric is available. Inbuilt face recognition. Inbuilt object detection. Only we have to give data set. Only we have to provide the data. We have to give, and by which way it will get data? In real time, it will get data from webcam. At the back end, we are having set of images of criminals, set of images of suspects or whatever it is. Okay, and I'm showing you its execution part now, by which way we can work on its execution. So I'm opening my is this command prompt visible to all participants? Please confirm. Is this command prompt visible? Now I'm starting its implementation part. Now I will show you how to run it, how to execute this code. So I'm showing you some source codes, and at end of this session, I will share all these source codes to the participants so that you can perform same thing in your system. Now I will show you very simple implementation. Few implementations we will discuss. This is the source code of Edge webcam. Edge detection from webcam. Is this visible to all of you? Notepad file visible? For edge detection, only in 15 to 16 lines of code after removal of blank lines and comments. So this is the type of code that we use in OpenCV. Okay, so in Python, first of all, we have to import the package CV2. CV2 stands for OpenCV. .video capture. I will show you the demonstration from my laptop. Okay, inside this laptop, we are having one webcam. Okay, and in this particular laptop on which I am working, it is having only one camera. So I will use here 0. And you will see that in real time, it will capture the images, it will capture the video, and in dynamic mode, its edge detection will be implemented. What is meaning of edge detection? Suppose we want to identify whether this person is human or animal. So using edge detection, can we do it? Yes or no? Is it possible? Difference between shape. So obviously, and shape of animal is different. Shape of human being is different. So rather than capturing entire video of object, can we use only edge detection or not? If I ask you, respond in chat. Using edge detection, can we identify whether this person is human or animal? Is it possible or not? In chat, please respond. Edge detection means outer area, only outline. Using only outline, can we identify whether this object is human or it is elephant? Whether this object is human or it is a tree? Yes, we can do it using edge detection. Now I'm running this code. Same execution of code we can perform on OpenCV inside open source hardware, that is Arduino. So I'm executing this code and you will see. So you will see, obviously I'm in front of the camera, you will see my video. Okay. So I'm sitting in front of the camera. I can't put here some animals, but I can show you my video. Is it visible to all of you? Are you able to view my video in dynamic mode? So you can see that. So we can set its parameter. So this is only edge detection. So if I close this, and now if I want to modify this to some particular level, suppose I have put here these values I have specified, and so you can see in this way. So same thing we can implement on open source hardware. So in dynamic mode, it will capture whether it is a human being or not, whether it is associated with whether this particular image is associated with some human or some animal. So now obviously this particular outline is similar to some human being. It is not similar to some particular animal or some particular tree. Okay, so we can say that, okay, with minimum coding, with minimum resources, we can identify that it is a human being. In case of cyber forensics, in case of law enforcement agencies, same thing is implemented. You might have seen on airports whenever we give our hand baggage for scanning, so they identify the suspicious objects in minimum resources. They first of all they capture the images inside that particular luggage. They match each and every object with a set of objects, whether it is scissor or not, whether it is a cutter or not, whether it is some liquid or not. If it is water bottle, then how much water quantity is there? Okay. So we can modify this code. So if I copy this code in a particular device, and I put that particular device on traffic light, in that case, in dynamic mode, it will capture video and it will identify whether this particular person is human or not. So you can see that if I am moving here and there, so it is in real time extracting that particular video. So, and how much lines of code you can see in only 15 to 16 lines of code. But if I perform same thing without OpenCV, I will have to write thousands lines of code. But with this CV2.video capture, it is dynamically getting my images. In dynamic mode, it is converting my image to grayscale. In front of camera, camera is actually getting images in RGB mode, in colored mode. But with single line of code, with single syntax, with single instruction, it is converting that in grayscale mode. So obviously, if we are having grayscale image, it will take less size. It will take less space in memory. So such type of implementations we can perform very effectively. Now, if I show you another implementation, so Harris corner algorithm, Harris corner. Okay, there is in case of machine learning, there is another algorithm for edge detection, that is Harris corner algorithm, to identify the edges associated with a particular object. So if I open this code, so you can see that in minimum lines of code, it can identify the outline of a particular image. And you can see that why I'm showing you, to show you the features of OpenCV. You can see that I have not written the entire code of Harris corner. Only this particular instruction I have mentioned. This API is called corner Harris. Harris corner algorithm is already available in OpenCV. There is no need to write its code. There is no need to write its complete implementation. Simply write Harris corner. Simply write random forest approach. Simply write artificial neural network. In single line of code, ANN will be implemented. In single line of code, support vector machine will be implemented. So all machine learning algorithms, all deep learning algorithms, all effective prediction algorithms are already available in this package, and it is freely available under open source distribution. So you can see that we can implement it for static image also. Suppose this is the image. Okay, I want to identify edges of this particular image. So you can see that in this I have put this image rajnikant.jpg. Okay, and icon Harris corner.jpg. It will identify the edges. Is it visible? For static image, we can identify the edges of any human being like this. Okay, now if I want to relate it, if I want to modify this code for webcam, suppose I want to modify this code for webcam. So Harris corner webcam. So rather than using this line rajnikant.jpg, I have put here cv2.video capture. In only single line of code, it is done. And you will see I am in front of the camera, so you will see my images. Harris corner webcam. So whatever you have seen in case of that image and its feature points, my features are getting extracted. You can see. Is it visible to all of you? You can see here. So at the back end, it is capturing my coordinates. So these are my coordinates. So these are my coordinates. So if I'm giving, so if I'm showing you hand, now you can see that my edges are extracted in real-time mode. So anybody can identify that that it is looking like a human being, or my face can be extracted and it can be matched with the faces of criminals like this. So if I'm moving it here and there, are you getting this image, this real-time image? So in this laptop, I have integrated one. There is one webcam. Okay, if same code I copy in a particular open source hardware, in that case, from dynamic images, it will perform the implementations. You can see. So all objects, and at the back end, you will be able to see my coordinates. These are my coordinate values, and these coordinate values, these numeric values, can be matched with the numeric values of criminals if we are doing it for criminal detection. If we are working on a research project for a particular implementation of social distancing, in that case we can relate these numeric values with some particular distance, that how much distance is there between two edges, between two objects. Okay, and obviously each and every type of object will be having its own coordinates, its own pattern of coordinates. Are you able to view it? Is it visible to all of you? So you can see that. So I'm showing, if I'm showing you mobile, so its corners will also be identified using Harris corner, and in only single line of code we can perform it. Okay, and you can see what we have done in this base code, corner Harris, and its complete documentation is available in free distribution on its official portal. Okay, and if I remove blank lines, remove empty lines, you can see that how much lines of code in only 19 lines of code. If I remove these comments also, I will be having only 15 lines of code. In only 15 lines of code of OpenCV, we are able to implement corner Harris. But actually, in actual implementation, corner Harris is implemented in only single line of code. That is very difficult to program separately. Okay. So is this point clear to all of you? Up to now, is it clear? Whatever we have discussed so far, that which are different features of OpenCV for machine learning, for robotic applications. So this is also a robotic application. This is also an automated application that is capturing data, that is capturing images, that is capturing video in real time, and it is checking different edges. It is identifying different edges or different corners of object. Is it clear to all of you up to now, whatever we have discussed so far? By which way we can work with automated applications? Up to now, any query, any question, any doubt? So, and as far as coding is concerned, these codes are already available on official website of OpenCV. So very good research projects you can propose, you can work with. Suppose you are working on a research project for blind people, that can also be done. In a particular stick, webcam can be integrated in real time. It is capturing images in front of it. Okay, and it is matching with the with some family members, with the images of family members. Okay, in that case, what that stick is doing, that stick is capturing data from webcam, matching with the family members, and it is telling that blind person that this person is your father, this person is your that particular friend. So that is also a research project that also you can work with. And such type of research projects are generally adopted, generally accepted by the organizations, whether it is DST or AICT, wherever you want to propose it. Automatic object detection, in real time face recognition, in real time object matching. Okay, up to now, is it clear to all of you that which are different features of OpenCV, what we can do using this platform, which type of applications we can work with OpenCV? Up to now, is it clear to all of you? Please confirm in chat. Any query up to now? So if I'm now I'm showing you one specific video. Okay, suppose this is some particular video. Suppose you want to work on a particular research project on some particular assignment for, is this for human detection? human detection or suspect detection on border area. Is this video visible to all of you? This is a very small video just for demonstration. I will perform one implementation of OpenCV on this video just to show you what we can do. Now you can see, suppose I am working on a research project, and in that I want to identify the motion. I want to identify human movement. So this is the actual video. This actual video may be from real-time webcam. Now, for that implementation within OpenCV platform of machine learning, background subtraction is already available. Background detection, background subtraction. What is meaning of background subtraction? So inside this video, this is the actual video. Inside this particular video, I have nothing to do with this park, this car, or this pillar. I want to see whosoever is moving, which type of objects are moving here. I want to see only those people. Suppose I want to propose a gun, I want to propose a missile for defense. That will automatically identify video from webcam. It will check whether some person is moving or not on border area, and automatically missile will be shot at that particular location where that movement is going on. So by which way we can do it? So by this way we will come to know. Subtract background. Is it visible? Now this type of implementation can be proposed for defense purpose, for automated guns. So whosoever is that person, whether it is a terrorist or not, whether it is opponent army or not, whether it is some other person or not, so its missile should be activated if some movement is going on. This is the actual video. This is actual video. Suppose from webcam, this particular video is getting captured in real time. So if OpenCV is integrated in a gun, in a particular missile, or in a particular tank, these longitude, latitude can be identified where these movements are going on. Suppose we are implementing this. So automatically these coordinates will be captured, and that particular gun or that particular missile will be activated at these coordinates. Okay, so obviously if some sensitive area is there on border area, then obviously there must be action. So whether you are working for blind people, or we are working for defense personnel, or we are working for human detection, this is also human detection. Now in this video you can see there is no pillar. There is, in this video, there is no static thing. All objects are available which are in motion. Is this clear to all of you up to now? Which are different applications of machine learning? So this is also a part of machine learning in which background is subtracted. Only human motion is available, and we can work on some research projects for defense, for police personnel. You can use such type of implementations for law enforcement agencies during curfew, if some particular movement is going on in night area. Is this clear to all of you up to now? That what we can do using OpenCV. If I change this video, suppose I'm modifying this video. It is suppose video of airport, and I want to see. Now you can see this. Only objects. so that corrective action can be taken. Is it clear to all of you up to now, whatever we have discussed, or it is not clear? Up to now, it's clear to all of you, whatever what we can do using OpenCV platform, and it can be used for different forensic applications, and there is no need to code separately. Each and everything is available inside this platform. So if I want to work with background subtraction, so you can see that immediately after video capture, it will work on, we can directly work with this, create background subtractor. Okay, so all APIs are available, all methods are available. There is no need to program explicitly. There is no need to write lengthy codes for each and every implementation. Each and everything is available in OpenCV. So you can see its documentation also. So motion analysis in OpenCV. On its official website, so you can see open source computer vision. On its official website, it is available. So we can see which particular function is available for which type of application. Okay, if I want to implement KNN algorithm, it is also available. By default, it is available. I can directly call this package. I can directly call this function inside my code, and KNN based prediction will be done. So you can see in real-time webcam also. So if I want to take real-time video, then what I have done, 0, video capture 0. So whosoever, so obviously I am in front of the camera, so it is capturing my video. If I'm giving some static image, then it will take from there. So it's up to you. So any type of video. So what you can do, you can simply put here 0. Okay, copy this code in Raspberry Pi or in Arduino board that is already having OpenCV, and you can put it on traffic light. You can put it in your drone. Okay, in your drone application, you can put it on in your institute, so that dynamically it will be able to identify the video. Okay. So is this clear to all of you up to now, whatever we have discussed? Please confirm in chat that what we can do using these pre-built platforms. So these are pre-built frameworks. OpenCV is pre-built framework for machine learning applications. Even you can put it in front of your car also. So whatever object it is getting in front of your car or from back of your vehicle, it is identifying the images and it is matching the objects from some specific set of images. Okay. So up to now, is this clear to all of you? Please confirm. Are you getting all these points clearly or some doubt? And how much you are finding, how much you are thinking it beneficial for machine learning applications, for robotic applications, whether it is looking difficult or it can be implemented with ease. You can respond in chat that how much it is looking beneficial for all of you and how much it is looking difficult for automated applications. Any query, any doubt up to now? If you want to discuss something, if you want to ask, you can write in chat that how much you are finding it beneficial. Are you getting audio clearly? Please confirm. Are you getting audio and
Yes, yes,
screen?
sir. Participant, you can unmute yourself if you want to discuss.
Oh,
The option is open. You can unmute yourself if you have any query. You can
okay,
ask.
okay. And are you getting, sir, whether audio is clear to all participants? Please confirm. You can please confirm.
Yes, sir, it's clear. It's clear, completely clear.
And all demonstrations are also clear, sir?
Yes, yes, sir.
Okay. So there are so many perspectives of OpenCV that is under free and open source distribution. Now, as now one example we were discussing for forgery detection, we will see one part of forgery detection or manipulation analysis. How to work on that using OpenCV? What we can do in case of OpenCV, the pre-trained modeling is available. Pre-trained modeling means we can give a set of images which are genuine images, which looks genuine, and if some particular real-time image or some particular real-time video is coming via webcam, we can check, we can match whether it is forged or not. Yes, definitely. These algorithms can be made more effective. All these algorithms are free and open source. These are under customizable mode. You can modify this function. So as I have shown you one, this, so its source code is available. Its complete code is available. So simply modify that code, recompile it, and you can take new results. Okay, it is not mandatory that you have to take only inbuilt functions. You can take, you can modify all these functions. It is fully customizable. Now I will show you one demonstration of forgery detection. For forgery detection, suppose you can see that we are having, this is one check. Is this visible to all of you? In chat, please confirm. Is this check image visible to all? Suppose we want to work on a research project for banking, for forgery detection in checks. So you can see that this is one signature. Suppose we copy and paste this signature in another document, that is income tax return, or we put these signatures on another blank check of that person, and we take it and we take its colored printout. I'm repeating this point. Suppose I'm having sample of your signatures. I can copy that signature because many times we give check to different people. Suppose they scan my signature on that check, and from somewhere they get access to my another check, blank check. So you can say it is very easy that colored printout can be taken on that blank check with that particular signature. So how to identify that these signatures are done with ink pen, with fountain pen, or it is a particular forged image? It is a forgery. Many times we also do same thing. You might have seen that whenever we send some copyright form to some conference or some journal, in most of the times we do not sign the copyright form. Generally what we do, we are having a sample of our own signatures. So whatever conference or journal is sending us copyright form, what we do, we simply insert picture from file, we insert our signature, and we finally make its PDF or JPG and then send that conference or journal publisher. I think you might be getting what I mean to say. Many times when we are asked to sign, to download a form, to give a signature and then again scan. In most of the time, in more than 95% cases, we do not sign. In our laptop, we are having our sample of signatures. So once we have done somewhere, we copy it from we have taken its image by mobile or by some scanner, and every time we copy that in MS Word by inserting picture, and finally we create its JPG image or PDF, and then we send it. But using OpenCV or using similar automated platforms, it can be very easily identified that you have not signed that document. That particular sign is inserted as an image, and after inserting image, you have made its JPG file or PDF file. Okay, now I will show you this demonstration. This is c1.png file. This is c2.png file. And using OpenCV, I will show you in single line of code, it can be easily identified that these signatures are copied and pasted. It is not done manually. that we also do in case of copyright forms. Even in case of many other instances, like filing returns or sending some particular form to somebody, simply copy signatures in paintbrush or Photoshop or MS Word, and we give it. And we think that nobody will be able to identify that these signatures are done by me or it is manually inserted. Okay, so I will perform this implementation on C1 and C2.png file. This is FLAN feature detection. This is C1.png, C2. So you can see that FLAN feature matcher, it is by default available. Feature detection, key feature detection, it is also by default available in OpenCV. And if I execute it, Python FLAN features, and I will show you its output now. It will identify the features and it will give us the pixels. You can see this. Is it visible to all of you that these so many green lines are here? Is it visible to all of you? So many green lines, it means that it is matching, that these two signatures are matching. That it is copied exactly from this signature, from earlier sample. If I take another example, if I'm showing you two more images. This is check 1, this is check 2. From this check 1 check 1.png, this signature is copied and pasted to some other document, and I want to identify whether these are genuine or not. So its name is cheq.png, cheq.png and cheq1.png. I will verify its name. This is 2.png, and we can now I will run it. Same thing we can perform in case of webcam, in real-time webcam also. So you can see zoom. I'm zooming it. So anybody can easily see that these two signatures, features of these two signatures are exactly matching, and these are not genuine signatures. It is copied from some other document and pasted or inserted as picture. Is this point clear to all of you, that how much power is there in OpenCV with pre-trained modeling of objects? In case of copyright forms, so in case of copyright form, there is no sensitivity. It is not sensitive matter. But checks or legal documents, these are sensitive. Okay, and if bank is willing to perform this thing, they can do it very easily using OpenCV platform. So what they can do, they even as a research project, you can work on it. You can create a device. You can create a particular machine. You can use a particular machine. Actually, as far as learning is concerned, as far as training is concerned, this is the query image that we want to analyze, and this is the train image. This is trained image. You can see that. And as far as its implementation is concerned, it is available in OpenCV, opencv.org, official website of OpenCV. So what you can do, you can propose some good research projects to income tax department. We can propose some good projects to some publishers. We can propose some good projects, uh, robotic projects for banking professionals, for banks, so that they can identify whether the signatures they are getting, that is actual or not. So this is training image. This is query image. You can take any other thing also. So if I'm taking some other object, so on any programming language you can perform it. Okay. So this is check one and this is check two. So some files I have already prepared in my system. So this is check one, G check one and G check two. So what I have done, one image of signature I have taken and I have modified it in Photoshop, and again it is put in some other. So this is G check one, G check two dot png dot jpg, G check one dot jpg. So simply what I'm doing, I'm simply changing the file names, and we can identify. Now you can see that in other cases there is very less matching, but in case of signature there is highest degree of matching. If I want to see the difference, if I want to see the numbers, if I want to see the values, in that case I will print all these things. So inside code, inside source code, I will print these values. Which values? This matches. Okay, matching percentage also we can find out. Okay, in this source code we can put some additional functions, we can put some additional methods for calculating the difference, how much it is matching, 80% it is matching, 90% it is matching. Main thing is you should be able to identify that how to work with this platform. Suppose you want to see its manual. So OpenCV, and you will see its code is also available, its manual is also available on this. Is it visible to all of you? Its source code is available. Suppose you are doing research, you want to take its Python code for customization, click on Python. This is the Python code. You want to take its Java code, click on Java. Its Java code is available. You can see its Java code is available. If you want to work with C++, click on C++. Its C++ code is available. And its demo is also given, that these are matching from this particular image. Is it visible to all of you? That multiple code. So we are not writing the code. We are only putting our data. We are only integrating webcam. We are only integrating a camera so that it can capture images and then it can match. So for multiple programming languages, its code is available. Is it visible to all of you? Are you getting these things? Please confirm in chat. Different codes of different languages are available. So I can use this code in Eclipse. In C++, I can copy and paste this code. Suppose I'm doing research, I want to improve its performance. What I will do, I will make modifications to this source code. And by this way, we can work on very good research papers, very good research projects for banking, for fraud detection, for human detection on border area, or for human detection during curfew. We can propose some projects of machine learning to law enforcement agencies, to military agencies, to defense organizations. If we want to work for blind people, we can propose very good projects identification of family members, identification of suspect. Now, up to now, there is no machine, there is no blind stick, there is no stick available for blind that can pronounce name of people. So what we can do, inside that stick for blind people, we can put a camera. Inside that, we can integrate Arduino board with OpenCV. Using camera, it will capture images in front of it, and then to that person, to that disabled person, it will using speaker. Okay, using speaker, it will tell that this is your father, this is your brother, this is your that friend, this is your friend Y, this is your friend Z. Okay, there is some obstacle at 10 meter ahead, there is some big animal in 50 meters ahead. So that is also a research project that you can propose to DST, AICT, or some corporate organization for uh, identification of dead bodies inside river. It can also be done, and this so many people are working on it. So whenever some accident happens in a river, whenever some bus or some vehicle penetrates or submerge in a river, then it is very difficult to identify the dead bodies, very difficult to identify how many bodies are there. So using webcam, it will capture images from all the surroundings, and it will identify, okay, which are looking to human being. Okay, it is not human being, it is a crocodile or it is a tortoise, but it is looking like a human being. This is a fish. So we can count that in a particular river, in a particular submerged area, how many dead bodies or how many living bodies are there. So that is also a robotic application. Are you getting what I meant to say, what we are covering here? So and up to now, is this clear to all of you? As far as learning is concerned, you can go for docs.opencv.org. On this, you will get simple codes. And as far as C++ learning is concerned, this query is concerned that is it necessary to learn about C and C++? There is no need to work only on C++. On any programming language you can work with, whether it is Java or MATLAB. Okay, and you can perform these implementations. I will share you all these source codes so that you can work with it. Yes, please ask your queries. I invite participants to please put your queries. If you have any query, if you have any doubt, if you need any discussion, you can please discuss.
Yes,
After
dear
this,
all, please post your queries in chat box. Sir, some queries we already have.
Yes, ma'am. Yes, ma'am. That we have queries we have addressed.
Okay, sir. The first query we have from KZ Mola. Can you please put actual two signatures and show the difference between both?
Yes, sir. That we can do actually because of time constraint. In real time, it is very difficult to put multiple signatures and scanning and then to implement it. I will share you this source code and then you can experiment it. If you face some troubleshooting or if you need some clarification, you can contact later on by mail also.
Okay, sir. Next we have from Mr. Ravi Krishan. Sir, how can we know which is original and which is copied one?
Yes, actually, you can see that in this particular code, we have mentioned that query image. First is your query image, and this is your actual image. Second, training image is your actual image, and query image on which we want to implement.
Okay. So next we have a question from Mr. Pushpinder Sharma, from where we can learn machine learning from scratch in continuation, which are simple codes and programs.
As far as best resource of machine learning is concerned, you can start with medium.com. Medium, there is one website that is medium.com and towardsdatascience.com. Towards data science and medium.com, and beyond it, we can work with OpenCV.org. It will be quite easy.
Gaurav sir, kindly open your webcam.
Yes, sir, I have opened. Actually, because of bandwidth issue, there may be some problems.
We have to take snaps, capture the moment. That's why I'm asking.
Okay, okay, okay. Sir, I'm executing that code using which we can perform it, because within Zoom there are some bandwidth issues. Is it okay, sir? So using script, I'm doing it.
Okay, that's fine, sir. It would be great.
So I'm checking. I'm executing it again. Please confirm, is it visible? Is it visible to all of you?
Yes, sir.
Priya, kindly
Because
take
of, because of network issues, I am avoiding it. There may be some bandwidth problems.
Okay, sir. Thank you so much, sir. It was a very interesting session. And we are done with questions.
I'm just sharing this presentation, whatever I have discussed in this session. I'm sharing my presentation just now, and you will be able to perform these things, these implementations in your system. I'm uploading it. To access mobile cam on your mobile cam from your smartphone, in that case, you will have to install OpenCV in your phone, and then you will be able to work with it. So is it received to all participants? I have shared my presentation of this session. Is it received to all? Please confirm. In chat, I have given the link of today's presentation. All of you have received this presentation. Please confirm.
Yes, sir, it's visible.
If you have any query, you can please ask, and after that, we will conclude this session.
We have one more query that
Okay.
the Sam is asking: how to assess mobile cam, sir?
Yes, sir. In mobile, actually, OpenCV is also compatible with mobile phone. So we can install OpenCV within mobile. Its app is also available. Android app, BlackBerry or iPhone app is also available. We can work with that.
Okay, sir. Thank you so much, sir.
Okay.
Thank you, Gaurav sir. We will meet
Thank you,
tomorrow at the same time. Next session will be resumed at 2 p.m. Attendance link will be posted in your WhatsApp group. Kindly mark your attendance. Thank you, participants.